So let's practice a few of these, more of these half-angle formula problems. I'm looking at problem number 40 here, and I want to use the half-angle formula to find the exact value. So for problem number 40, let's let the half-angle be equal to that 22.5. So if I wanted to solve for theta, I would find out that theta has to then be 45 degrees. Now that's a value I know from the unit circle. So if we are using this idea, then I'm going to say, okay, well the cosine of my half angle is equal to 1 plus the cosine of theta divided by 2. And here we've used theta, we've stated that theta is equal to 45 degrees. So that's the value we're going to plug into my formula. So I have 1 plus the cosine of 45 divided by 2. And I know that the cosine of 45 degrees is the square root of 2 over 2. Now all of that's divided by 2 under the radical sign. Now if I kind of come in here and try to get rid of my fractions, I'm going to multiply numerator and denominator up under that radical by 2 over 2. That gives me 2 plus the square root of 2 in the numerator, all under the radical sign still, and the denominator is simply going to be 2. Because when I multiply the 2 up under the radical times the blue 2, I get 4. If I take the square root of 4, I'm left with 2. Now, remember that the half-angle identity for cosine says I have both the positive or negative values since I'm taking the square root. Well, because my angle I started with, which was 22.5, is in quadrant 1, then the answer, when I take the cosine of that angle, 22.5, has to also be positive. All right, let's look at another one. This time I want to look at number 42 here. I want to talk about the sine of 105 degrees. Again, I'm using the half-angle formula to do that. So the sine of 45 degrees, so this is problem number 42. If I let the half-angle be equal to 105 degrees, that's what we started with, then theta must be equal to 210 degrees. Again, 210 is a value off the unit circle I know, so this is going to work out for me. So I'm trying to find the sine of theta over 2, because that's 105, which is equal to, according to my formula, 1 minus the cosine of theta divided by 2. Now let's deal with the sine of this function in just a minute. Right now I'm just going to simply substitute into my formula here. I've got 1 minus the cosine of 210. All of that's divided by 2. I know that the cosine of 210, which is in the it's in the third quadrant, and the cosine of 210 has to be negative square root of 3 over 2. All of that's divided by 2 underneath that radical. So we're going to do the same thing we did in the previous one. I'm going to multiply top and bottom by 2 over 2. That gives me, underneath the top in the numerator, a 2 plus the square root of 3, all under the radical, and I'm going to divide that by 2. Because 2 times 2 is 4, take the square root of that, and we end up with 2. Now, we need to figure out what the sine of this function is. 105, which is what I'm ultimately finding the sine of, falls in quadrant 2, so the value of my answer, or the sign on my answer, is positive. All right, last one we're going to do in this set. I want to go back, and this time let's do a fraction one. So I'm going to find out what the tangent of 3 pi over 8 is using the half-angle formula. This is exactly the same process that we were just doing. So again, since we're told to use the half-angle formula, we're going to let theta over 2 be equal to 3 pi over 8. So if I solve for theta, that leaves me with theta equal to 3 pi over 4. So now we're going to apply the half angle formula for theta. And remember, we've got 3 choices to use. I'm going to choose the one that has 1 minus cosine theta in the numerator and sine theta in the denominator, because I wanted a denominator with a single number and not an addition part. So I've got in the numerator 1 minus the cosine of 3 pi over 4. All of that's divided by the sine of 3 pi over 4. So in the numerator now, I have 1 minus. Now, the cosine of 3 pi over 4 is going to be negative square root of 2 over 2, because cosine's negative in the second quadrant, and the sine of 3 pi over 4 would be positive square root of 2 over 2. Now I have a compound fraction here, so I'm going to show you something that I'm going to do. I'm going to go back and I'm going to rewrite the square root of 2 over 2 in its unconjugated form. In other words, I'm going to leave the radical in the denominator to kind of eliminate one of my steps here. So remember, 1 over the square root of 2 is the square root of 2 over 2. I have what you're looking at here, a compound fraction, and so I want to get rid of my compound denominators. So I'm going to go through and I'm going to multiply the top and the bottom by the square root of 2 over the square root of 2, because that's the denominator that I have in each case. What that gives me in a quicker step is the numerator, which now looks like the square root of 2 plus 1 when I distribute each of those. And the denominator, what happens down here to the denominator? That square root of 2 cancels with that square root of 2, and it leaves me with just a 1. So this is actually the answer. So I was kind of able to do a step in there by changing back 1 over the square root of 2, by changing it into 1 over square root of 2. Okay, so I hope that is maybe further clarification on how to use the half angle formula in this particular case.